Hello everyone and welcome to the first class of the last week of this course. Today we are going to talk about diets and how to study them with trace elements and isotopes. The diet corresponds to the characterization of the food ingested by an individual or a population. And the study of the diets allows us to have a look at the food available at the time, the access to the resources, and the livelihood patterns. There are several ways of studying diets with direct and indirect methods. In the indirect methods, it's possible to study Paleobotany, for example, examining the pollen grains, Faunal studies, and here can be studied the bones of animals. Sometimes it's possible to see marks of cuts that were made with utensils to deflesh the animals. And finally, the study of these utensils. In anthropological record, it's possible to look at some aspects of the morphology of the skull, especially the size of the teeth and the size of the mandible. They are very important to process food, and we know that bigger teeth and bigger mandibles imply food that is harder. And then, in the oral pathologies, it's possible to analyze, for example, the caries. They are a consequence from diverse factors, but usually they are associated with a diet rich in sugars. And then we have the direct methods. It's possible to analyze the trace elements that are present in the mineral part of the bone, and the analysis of isotopes, analyzing the mineral and organic part of the bone. And both of them consist in a chemical analysis. And how is it possible to obtain information about the diet from the bones? The bone tissue requires nutrients continually during the life of the individual because it's always remodeling, and this information is saved in the bones. Depending on the type of bones, we can obtain information about the diet from different time intervals. The compact bone is slower in the process of remodeling and the spongy bone faster. So, for example, in the femur we can obtain information about the diet from 10 to 20 years before death, and in the ribs from less than 10 years. Now we are going to look at the analysis of diets using the trace elements. First, the trace elements are chemical elements that exist in the living tissues in very small amounts, around micrograms per gram. And there are two assumptions for the analysis of this. First, the elements found in the bones reflect the type of food ingested during life, and the bones require nutrients continuously during the life of the individual. The trace elements that we are going to talk about are the calcium, strontium, barium, magnesium, and zinc. The calcium is one of the major elements of the bone and is essential to the growth during the life of the individuals. High quantities of calcium are representative of a diet rich in milk and derivatives, and low quantities are representative of a diet with low intakes of cereals. Now the strontium, and to understand this element, we need to look at the trophic pyramid. If you aren't familiarized with this, I left you a link of a small video that explains what it is. So in the trophic pyramid, the first level, and the first level is this, are the producers, which are the plants. And the plants don't discriminate the strontium, and this means that the plants have the higher quantities of strontium of all the trophic levels. It suffers fractionation through the trophic levels, meaning that its quantity decreases when we go to higher trophic levels. So, high levels of strontium points to a diet rich in plant-based foods or mollusks, and low quantities to a carnivore diet. This element is very important in the study of diets with trace elements. And before we go to other elements, it's important to know that all the trace elements are studied based on the proportion between the element studied and the calcium. And this happens because the calcium is constant in all the trophic levels. To analyze this element, there's an index called the corrected index. Basically, this index tells us the proportion of strontium-calcium in the human bone and in the bones of herbivores found at the same place. This value varies between 0 and 1, and when this value is closer to 1, there is a greater amount of plant foods consumed. And this happens because, as I said in the last slide, the strontium has high values in the lower trophic levels. So the barium is insoluble in marine water, which means that the animals that live in this environment will have low quantities of this element. Therefore, if humans eat a lot of marine animals, they will also have low quantities of barium. On the other hand, high quantities reflect a diet rich in vegetables or terrestrial foods. The magnesium is an important component in the chlorophyll, which means that there is a big quantity in green plants and low quantities in meat. The last element that we are going to talk about is the zinc. When the zinc is analyzed, we only see if the individual had a high, medium, or low consumption of foods of animal origin. When the proportion between zinc and calcium is higher than 0.5, this means that the diet is rich in foods of animal origin. When the proportion is between 0.35 and 0.5, this means that there is a medium consumption of foods of animal origin. And when the proportion is lower than 0.5, this means that the diet is low in the consumption of foods of animal origin. For you to understand this better, I will give you two examples with the two elements that are usually used, the strontium and the zinc. In the first population, we have a corrected index of 0.89 and the proportion of zinc-calcium of 0.25. The corrected index is close to 1, so this points to a diet rich in plant-based foods. Then the zinc-calcium proportion tells us that they had a diet with few foods of animal origin. And bringing this information together, it's possible to say that this population had a diet mostly plant-based. Now we have a population 2 that has a corrected index of 0.5 and the proportion of zinc-calcium of 0.65. The corrected index of 0.5 points to a diet with some kind of intake of plant-based foods. And the zinc-calcium proportion tells us that they had a diet rich in animal origin foods. And bringing this information together, it's possible to say that this population had a diet mostly of animal origin with some intake of plant-based foods. Nowadays, trace element analysis is not used much. It's used isotopic analysis rather. And now we are going to talk about the stable isotopes of carbon and nitrogen, which are the ones analyzed to infer about diets. The analysis of these isotopes allows the identification of consumption of different types of plants as well as food from marine or terrestrial environments. And before we start talking about the isotopes, it's important to know that they are chemical elements that have the same number of protons and electrons but different number of neutrons. And the stable isotopes of carbon are the carbon 12 and 13, and the stable isotopes of nitrogen are the nitrogen 14 and 15. Although the isotopes are similar in their chemical properties, they behave differently. They have different velocities in the reactions, and there's an important process called isotopic fractionation that is defined as the relative partitioning of the heavier and lighter isotopes between two coexisting phases in a natural system. And this is the process that allows us to the study of diets. So this equation, this one here, is the equation that is used to obtain the values of the variation of carbon and nitrogen. The R is the ratio between the number of atoms of the heaviest isotope and the number of atoms of the isotope more abundant on the same food. And what this is telling us is that we are seeing the isotope fragmentation of a certain isotope. Imagine that we are analyzing the carbon in the human bones. We need to know how much was gained during the food chain. So imagine that the grass has a value of carbon of 1, and if a rabbit hits that grass, it will have +1 of carbon. And if a fox hits the rabbit, it will gain the carbon of the rabbit that was already higher because he ate the grass, and so on. And this is what we are looking for in the isotopes. But don't worry, there are intervals of values so that we can analyze the samples. And I don't want you to know all of these technical parts of the analysis. I just brought them so that you could have an idea of how it works. I just want you to know how to apply the intervals and values that we are going to talk about next. With the carbon, we can distinguish between the consumption of C3 and C4 plants. And for who doesn't know, the plants can be divided into C3 and C4 based on their process of photosynthesis. The C3 plants are the ones from temperate zones, and we have, for example, the wheat, rice, and nuts. They have values of carbon that vary between -9 to -14, with a medium value of -12.5. Then the C4 are the grasses that are adapted to hot and dry conditions, for example, the corn and the sugarcane, and their values vary between -20 to -35. With a medium value of -26.5. And then there is also the chem plants. They are the succulents and the plants that are adapted to the desert. And they have values of carbon between the C3 and the C4 plants. In the case of these plants, it's important to have in mind the place where the bones were found, because it's possible to have values between the C3 and C4 that aren't for chem plants. Imagine bones found in a place where there wasn't deserts. It doesn't make sense that they hate this type of plants. With the carbon, it is also possible to distinguish between food from marine or terrestrial origin. The value of carbon for terrestrial diet has to be under -19, but it's only possible to use this value when there aren't C4 plants because their values overlap. And we know that the C4 plants only appeared after the Neolithic. In marine diets, the values of carbon are above -19. And now the nitrogen. With it, we can see if the diet is based on terrestrial or marine food. An exclusively marine diet has a value of nitrogen of 15 and a terrestrial diet a value of 9, and the breakpoint between them is 9 or 10. Also, with the nitrogen, it's possible to infer about trophic levels. There's an increase of +3 of nitrogen in each trophic level. So, taking both these things into account, if we have a value of carbon, for example, of 12, we are talking about a marine diet of low trophic levels. But if we are talking about values like 20, this is a marine diet of high trophic levels. But in the next slide, I will show you a summary of all the things about the isotopes. In this slide, you have a summary of what means each value of both the nitrogen and the carbon. And I recommend you to have this information when you are making the quiz for this week. And now we will apply the analysis of the isotopes. First, it's important to know that when a population is being analyzed, there are values of carbon and nitrogen for each individual that was taken a sample. And with these values is made the average of carbon and nitrogen for the population. So now we have a population, and at the time that this population existed, there were no C4 plants, which means that we can distinguish between marine and terrestrial foods using the carbon. So now we have a value of -20.7 of carbon, and this value tells us that the population ate mainly terrestrial foods with C3 plants. And then we have a value of 9.8 of nitrogen, and this tells us that they ate terrestrial animals of high trophic levels. So in general, we can tell that this population had a diet mainly terrestrial with consumption of C3 plants and terrestrial animals of high trophic level. Now we have a population 2 and there were C4 plants at the time, so it's impossible to distinguish between marine and terrestrial foods. The value of carbon tells us that this population ate predominantly terrestrial foods with incorporation of C4 plants or marine food. Once we know that at the time there were C4 plants, we can eliminate this part. And then the value of nitrogen, which is 12.6, tells us that they ate marine animals of high trophic levels. So in general, about this population, we can say that they had a diet mainly terrestrial, maybe with C4 plants, with incorporation of marine animals of high trophic levels. I note that this topic of diets isn't the easiest one. There are some knowledge of the areas of chemistry that is needed to understand everything, but I think that this is a really interesting topic, so I tried to make a simple summary of everything. With this class, my goals were for you to see that it's possible to have a general idea of the diets of past populations, and that there are several methods to analyze them. Also, that between the trace elements and the isotopes are the most used. And finally, I hope you are able to interpret some data about the isotopes and trace elements with information that I gave you. I left you a chapter of a book that explains all the processes in the analysis of diets, but if you have any questions, please let me know, and I will see you in the next class about paleopathology.